Today we're looking at U-substitution, a technique for integration that works by reversing the chain rule. The rule says if u equals g of x, then du equals g prime of x dx, and the integral of f of g of x times g prime of x dx becomes simply the integral of f of u du. The whole point is to rewrite the integral entirely in terms of the new variable u. There's a companion technique called integration by parts, which is really the product rule run backwards. It says the integral of u dv equals u times v, minus the integral of v du. There's also an important application worth remembering, the area between two curves. If f of x is greater than or equal to g of x on the interval from a to b, then the area between them is the integral from a to b of the quantity f of x minus g of x dx. Now let's work through an example. We want to evaluate the integral of 2x times cosine of x squared dx, and we'll use u-substitution to do it. Let u equal x squared, then du equals 2x dx. Notice this matches exactly what already appears in our integral, so nothing extra needs adjusting. Now we rewrite the entire integral in terms of u. The 2x dx becomes du, and x squared becomes u, so the integral becomes simply the integral of cosine of u du. Integrating, we get sine of u plus a constant. This is a standard integral, so this step is quick. Finally, we substitute back, replacing u with x squared, since that was our original definition. The final answer is sine of x squared plus a constant. Here's the trick to choosing a well. Pick u to be the inside of a composed function, matching the inner function idea from the chain rule. If, after substituting, you still have leftover x terms that refuse to cancel, that means u was chosen incorrectly, and you should try a different piece of the integral instead. Now, the most common trip up with u-substitution, forgetting to convert dx into du completely. This leaves a mixed expression containing both u and x together, and then integrating that mixture as though it were purely one variable, which gives a wrong and meaningless result. Here's a teaching tip to avoid that mistake. After substituting dou no x left behind, scan the rewritten integral carefully and confirm that every instance of x and every dx has genuinely been replaced by u and du. And for integration by parts, use the fixed order, logarithmic, inverse trig, algebraic, trigonometric, exponential to decide which piece of the integral should be chosen as u.